Now we are going to start with the point where we have left last day. Last day we have started with equivalence relations. We studied some questions of equivalence classes, etc. So now we'll be taking some problem related to that. Okay? And then we'll start with function quickly. Let's see whether we'll be able to start functions or not today. But we'll be starting some questions first. Let us go for that. Question number 1 of today's, right? You write down the question. Let A is this. You note down, just I'll not read it. You just note down. And okay. So once you finish writing, please raise the hand. Okay, now you see first, before I proceed further for the questions completely. Earlier we had sets defined A only, right? Like a relation R is defined on a set A. In that case, R is a set of subset of A cross A. But this time we have told that R is a relation defined on A cross A. That means R will be a subset of A cross A cross A cross A. Just try to understand that meaning. This is an extension. This is an extension. That is the thing you should know. So just I'm writing once more. This time, this is a small work just to understand. If I consider this as another set B, R is a relation on B cross B. That means this time R is a subset of B cross B. And as each B is of the form A cross A, elements from this will be always of the form ordered pair. So B cross B element will be ordered pairs of ordered pairs. Remember. So this is the thing you have to now understand. So with the help of this, we'll proceed now for showing that it is an equivalence relation. So we'll just start with. So here, first one, once we'll be writing this as a part of formal answer. AB, comma, CD. These are related if A plus D equal to B plus C for all A comma B and C comma D belongs to A cross A. Now, number one. Number one means we have to see the reflexibility. For for AB, any element, right? AB here in the is the confusion of it. For AB, any element in where A cross A, right? If I can say that A comma B is related to itself, then I can say it will be reflexive. So now just see for any element A comma B in A cross A, can we get this? A plus B, sorry, A comma B related to A comma B or not. So directly you can write it like this. A plus B equal to B plus A. So this is true. There is nothing wrong here. Now you just compare. A is here, A is here. B is here. Acha. Had the ordered pair been like this, A and B are going for which places? First and the third. First and the third. Okay. This will tell you that AB is in the relation. And then CD is going where? C is here and D is here. So this is C, this is D. Can you compare that? So that this will tell you A comma B is related to A comma B, right? This related to A comma B. So that means A comma B comma A comma B is belonging to R. Therefore, R is reflexive. Please see this. Right. Now, for A comma B and C comma B, D belongs to A cross A. I have to show for symmetricity. So symmetricity means I have to first start with the relation between this. These are related. So I have to show that the reverse is also related. That means C comma D, comma A comma B will be related. So if I apply the definition of relation, I'll be getting this as this much, right? So from here I should get C comma D related to B comma A. So now just you see, in order to relate C comma D to A comma B, what I should get here, right? So can we construct that? So that should give you what? C in place of A and D in place of B. See, this is the order we are going to write. So C in place of A, right? And D in place of B. I have written like this. And then here CD. So C goes to this place. So here I should get A and I should get here B. So can this be true? Is this true? Yes, it is true. I have not done anything, right? Only I have rearranged, reshuffled. This I can do. So this will definitely imply C comma D, right? C comma D and A comma B will be related, right? So you see, can I just follow this definition to obtain this? C plus B, because A plus D should be written. So C plus D I have written, C plus B I have written. Then here B plus C should be written. So D plus A I have written. So you might have understood. So therefore what I write, R is symmetric. We'll be going for the transitive one. First you finish this and raise your hand. Okay. So I'll go for the next. Now we are going for transitive, the third part. So for transitivity, we need three elements. We have got this. This belongs to A cross A. Now, yeah, we can start like this, such that we have to get these two related. That means this ordered pair should be in R. Then C comma D, E comma F, this ordered pair should be here. This will imply what you write. A plus D will be equal to B plus C. This is one. So from here, what will I get? C plus F will be equal to D plus D plus. So this is what we get. Now, what is your target? Just you see, always you try to keep it in your target in your mind. Always keep the target in your mind. I am just writing the target here first. My target is to show that this is related to EF. It means I should arrive at A plus F equal to B plus C. If I arrive at this, then I am done. That's the step you have to get. That's the step. This is the problem solving idea. Right? So what I'll do here is this. I want to add both the results. Right? These results and this result. These both results I want to add. So if I add the result, then left side plus left side and right side plus right side I add. Then you see what are being cancelled. D will be cancelled out and one more. C will be cancelled out. Okay, very nice. So once it is cancelled out, you are left with AF and you are left with B plus this. So this directly implies us that A comma B is related to E comma F. That means it is belonging to R. Therefore, R is, sorry, transitive. R is transitive. So we have proved. So now what will be our conclusion? Therefore, R is equivalence relation. It's a good problem. Please note down. And then actually one part, additional part will be there. That part I think I did not write in the question. Anyway, no problem. But I'll be doing it here, marking it as second part. You have to find this equivalence class of 2 comma 5, 2 comma 5 equivalence class 2 comma 5. That means here I should write all those ordered pairs which will be related to 2 comma 5. So here you do not need the extra work, just little rough work you have to do. So suppose 2 comma 5 is related to a comma b. I have to find all these a comma b, right? So how will I be relating them? 2 comma b, sorry, 2 plus b should be equal to 5 plus a, right? So from here you go on finding. From here you go on finding. 1 to it is very clear that 2 comma 5 itself will be related, right? Then what number you can put here? If I put 1, a equal to 1, what will be the value of b? It will be 6, right? Because 2 plus 6 will be 8. Sorry, 4. I'm sorry. 5 plus 1 will be 6 and 2 plus 4 will be 6. That means 1 comma 4 will be related. Very nice. Okay, 0 I cannot take because 0 was not there in the set. Minimum value 1 only. 2 already I have taken. I think a equal to 2 already here it is taken. Right, so that already is done. Now you take a equal to 3. If I take a equal to 3, sum will be 8. So how much will be b? It is how much? 2 plus 6, yes, 3 comma 6, 3 comma 6, right? Then what else I can consider? 4 I can consider. So 5 plus 4, 9. And then 2 plus how much will be 9? 7 will be 9. That means 4 comma 7. Right. Can I take 5? 5 plus 5 will be 10. So 2 plus 8. If I consider 5, it is 8. 6 if I consider, it will be 11. And then 9. After that I cannot move because I do not have number greater than 9. That is the biggest possible number. So this is the equivalence class of 2 comma 5. Please observe that and note it down. Once you finish, please inform me. Do inform me. Okay, that's a good question. We finish. Now we'll be going for the another question. Question number 2 here. This is also equivalence relation only. We'll be doing this. A relation R is defined on R, this time on the real number, as the relation is given like this. Elements A and B, they are related. If A plus B, sorry, A plus B, A minus B plus root 3 belongs to Q, and AB are taken from real numbers. These are taken from the real numbers, right? Examine if it is reflexive, symmetric, and transitive. What type of relation it is? They are asking you to find it. Right? So this time they are not saying it is equivalence or not. They're just asking you to verify. Okay. So we'll try one by one. Right. Okay. So last day also I told you, when somebody asks you to examine, then we should always thinking it little differently. There may be possibility that it may not be uh, equivalence, right? So we try to look for the counter example. So here also we'll do the same thing, right? Okay, for A plus B, sorry, for reflexivity there is no problem. Directly we can see only it is reflexive. Like we can write for A comma, sorry, A belongs to R. If we need to talk about reflexivity, I should say these things. A plus A, these things. These things should be belonging to Q. Then I can say, will this belong to this irrational? Yes, because it is root 3 and that belongs to Q. That means, sorry, what I did, it is just a minute, just a minute. This Q, it is Q. No, it will not belong to Q. Because if I write A and A here, so whatever may be the value of A, I pick from real number, always root 3 will be left out. Always root 3 will be left out. So root 3 is not a rational number. So therefore it doesn't belong. That means what we'll see, A cross A comma A does not belong to R. So can we say that R is reflexive? It is not reflexive. Good. It is not reflexive. Now let us try for symmetric one. Let's see what will happen. Right? It is not symmetric as well, right? It is not symmetric as well. So for that directly we'll consider the counter example. So first we'll get the conclusion in this case. It is not symmetric as well. It is not symmetric as well as, not right as here, it doesn't look nice. As for A equal to, suppose A equal to this things you considered 2 minus root 3, 2 minus root 3, and then B equal to 2, you have considered. This, for this, what will happen? 2 minus root 3 minus 2, that is A minus B plus root 3. This is going to give you what? 0, and 0 belongs to Q. That is, you have got 2 minus 3, 2 minus root 3, comma, this belongs to R. But what will be the reverse? 2, this time B will come forward, and then minus 2 minus root 3 plus root 3. What will be the answer ultimately? 2 root 3, and this does not belong to Q, right? Therefore, you can see that this does not belong to R, right? Thus, A comma B belongs to R does not imply B comma A belongs to R. Therefore, R is not symmetric. R is not symmetric, right? So please write and indicate me. Once you finish it, we'll go for transitive. It will not be transitive as well. We'll look for examples. Hmm, good. We'll go for the next one. Here we'll show that it will not be transitive. So we'll look for counter example. So at the beginning, let me be mentally prepared. I should start with what? A, B, that is, if A and B will be related, it will tell you what? A minus B plus, this should be rational. It is a rough form, so we'll not write formally. then I should get B comma C related. I should get this to be rational, whereas I should not get this as rational. It should be irrational. It should be irrational quantity, and this should be rational. So I should be arranging these values in such a way that this is to be true, right? Let us just see. We'll look for the examples. It is not transitive as well because because for first of all we have to see in such a way that this should contain some irrational quantity till the last moment, but this should not contain any irrational quantity. So you try to adjust it like this. Hmm. So let me keep it like this. This should be rational. 2, then okay, 2 minus root 3 only, let me consider this, and then b equals 2, b equals to 2, or 3 I consider, and then one more b you consider, sorry, b equal to 3, no, one more b you consider. So we have considered this, very nice. Then if this, what we get, 2 minus root 3 minus 3 plus root 3, that is going to give me what? That is going to give me minus 1, and that belongs to Q. Right now I should start with the same B. Now I have to arrange a C such that addition will give me again what value? A rational value. So here I can write 4 plus root 3, suppose 4 plus root 3. I give 4 plus root 3. Then what will happen? 3 minus 4 minus root 3. Then, oh sorry, it is plus. What will happen now here? It will be, luckily or coincidentally, this is minus 1. Okay, forget about that. Just a minute. Okay, so here this is minus, minus 7, minus 1. Oh, just a minute, Swan. I'll just close this. Okay, so this is here. Okay, that means here I can write the conclusion also that A comma B belongs to R, then B comma C belongs to R, and now I have to talk about A. A is what? 2 minus root 3, and C is what? 4 plus root 3. Then what do we say about their differences? This minus 4 minus root 3 and then plus root 3. This will tell you that this is A minus C, right? So what is the answer here? 2 minus 4 will be giving you minus 2, and here only one root 3 will be cancelled, and the other root 3 will be left out, plus root 3. That says that it doesn't belong to Q, right? Therefore, what I said, this doesn't belong to R. Thus A comma B belongs to R, B comma C belongs to R does not imply A comma C belongs to R. Or this would happen for all ABC of this category, right? But this doesn't happen. Therefore, R is not symmetric. It's a good problem. So we have to this. Sorry, again I have written symmetry. It is not transitive. Sorry. A R is not transitive. Once you finish, please raise your hand. So I'll add one more question from my side here. Right, question number 3. Everything will remain same in the previous question. Only thing is that here this time this I'll write that it is belonging to the irrational. Everything is same. This is homework for you. This is homework for you. Everything is same except this particular set. Okay? Raise the hand once you finish it. Okay. I'll go for the next question. Here is your next question. Let us define a relation R on n cross n. N cross n means this n is natural number. This time also order pairs we get as a comma b comma c comma d. They will be related. The condition is that ad whole into b plus c, bc whole into a plus d. Right? Where this a plus a comma b and c comma d are taken from this set n cross a. Right? So that it is equivalence relation. So that it is equivalence relation. It is means this R is equivalence relation. Please note the question and then you let me know. So as a part of formal write-up, we'll write again. Here R equal to A plus B. This is a bracket here. So, A comma B, C comma D. These are related. AD whole into B plus C equal to BC whole into A plus D. Okay, these elements will be there. Where A comma B and C comma D are belonging to n cross. Now I have to see this is related reflexive, symmetric, and transitive all because they are asking you so that it is equivalent solution. So first we are going to show it to be reflexive. That means A comma B should be related to A comma B. So we write for A comma B belongs to n comma n. See, just I'll put the relative values and I'll see whether it will be true or not. This is something I want to do in a rough so that I will use this. If I want to say that AB is related to this, then what I should get AD, B this, and then BC, A plus D. Which element is going which particular place, you try to see that first. A is going to this place. Also, this A is going to this place. Right? And then B is going to which place? B is going to this place, and also B is going here. So these are the things we have to be very clear here. This is one. And another color I would like to use about C. This C is going to this place, and then it is going to this place. Right? D I'll not write. D will be the empty one. Now you can write. So I want to write the elements A, B in that order. Just to see whether I can write this or not. So I can write A here. If I get in this place AB, what should be my relation? A here and D. D means it is B. And then B plus C. B plus A it will be. B plus A. Right side should be what? BC I have written. BC means it will be BA, not comma. BA whole into A plus B. Are they equal? Is this expression valid? What I have written. Just you see, is this expression valid? It is valid because AB and BA are same. B plus A and A plus B are same. It is true. That means this will definitely imply A comma B related to A comma B. That will imply what? A comma B ordered pair A comma B, this will belong to R. Therefore, R is a fixed. Right? Once you finish, please tell me. This is again important question. Remember, very important. Okay. Now we'll go for the next. We'll try to see the symmetry. For A comma B and C comma D belongs to n cross n, I have to start with this relation. This belongs to R. If this belongs to R, what I got it says AD whole into B plus C, AD whole into B plus C, and then here it is BC whole into A plus A, right? This is what. Now I have to rearrange. I have to rearrange this, right? So here only you can rearrange or you can write the other part also. That is, choice is yours, but I'll rearrange. But to rearrange, I have to just see how this will be related. If I'm saying that these two are related, how or how the equality comes? AD. That means first and the last should be multiplied. That is these things, and this should be added. D plus A here, and then this should be multiplied, and first and the last should be added. Okay, very nice. So you just rearrange everything. D A I can write, and C plus B I can make it, and then this is CB, and I can write D plus A. And in the next step, what you can do is just the reversal. D plus A equal to DA C plus B. So this is going to give you C comma D related to A comma B. That means C comma D comma A comma B is belonging to R, right? So we got the reverse. Therefore, R is symmetric. Please see that. Please see this. Once you finish it, you tell me. Okay, now we'll be going for the transitivity. Acha, before going to transitivity, just one small work we can give you. This work we could visualize before also, because transitivity is not going to be very comfortable to show. So we are looking for this alternative. So this can be written as what? Just you see, if I get these two related, then I collect the same letter like AD I bring down and BC this side you bring. So we could have started this in the previous relations also. So that going to give you, that going goes to give you what? 1 by B, 1 by C, and then this is 1 by A, 1 by D. Right? So this is going to give us a good idea how we get, you see. If I'm talking about these things, if I'm talking about AB related to CD, then 1 by A, 1 by D should be in one side, that is first term and last term reciprocal, and middle term reciprocal should be in the in other side. So this is what we can use now for transitivity. So I'm going for the next one. Can I move? Yes, I'm moving. Now you see. This we are going to use transitivity. For A comma B, C comma D, and E comma F belongs to n cross n, I should start with two elements group like this. This is related. This belongs to, we should start with this. And then this should relate to EF. Now this will imply what? By the definition, AD B plus C equal to BC A plus D. In the other part, what will happen? It is CF, then D plus E, DE, C plus F. Now you can see, if my relation will be kept in this particular condition, it will be very, very difficult to segregate, because in my ultimate result there should not be any presence of C and D, and it is all mixed. So we have to go for that alternative idea. So here directly I can write, here I can write this as 1 by B 1 by C equal to 1 by A plus 1 by D. Here what I can write, 1 by D plus 1 by E equal to 1 by C plus 1 by F. So idea remains the same. I am to be left with AB and EF. C and D should be cancelled out. So here simply sum these expressions. This expression you add up with this. So if you get that, what will I get? Left side, this is added with 1 by D plus 1 by E, right, will be equal to 1 by A plus 1 by D plus 1 by C plus 1 by F. And now just look for which term will get cut. See, this 1 by C and this will get cut. 1 by D will get cut here. So now once they will be cancelled, this is 1 by B, 1 by E, and then 1 by A and 1 by F. Now from here, using that idea, can I directly write? I can write directly, right? Or else you can show the simplification also, but no need, because already you have come to know about the idea. So here AB will be related to E comma F. They are related, that means they are belonging to this. So if you write, you can write a concluding step. I'm not writing that, but in a formal answer you should write R is transitive. Therefore, R is equivalence. Very, very important question. Please, once you finish it, let me move it. Okay, so now we'll go for the next question. Next question is actually a theorem, so that I have written in the form of a question. Question number 4. If R1 and R2 are two equivalence relation on a set A, then so that R1 intersection R2 is also an equivalence relation. Equivalence relation on, but R1 union R2 is not always equivalence. That means union may not be always equivalence, whereas intersection of two equivalence relation is also equivalence. So we have to write this. So first we are going for the main part, this one. So let it like this. Let R1 R2 be two equivalence relation on A to show that R1 intersection R2 is also equivalence. Equivalence means all the three conditions should be satisfied. So one by one we'll see now. First we'll go for the reflexivity. For A comma A, right? For A comma A belongs to, sorry, do not start with A comma A. You start with A. Yeah, very good. For any element A belongs to A, you can say that A comma A belongs to R1 and A comma A belongs to R2. Why? Very clear, because since both R1 and R2 are reflexive. Why? As they are equivalents. So if this is there, both these elements, this would be A. So some error is there. Is A comma A belongs to R1 intersection R2. So this is telling you what? R1 intersection R2 is reflexive, because this relation is going to be true. This condition is going to be true for every A. Now number two, for any two element A comma A belongs to this, I should start with this belonging to this. Now I have to say that B comma A belongs to this. So anyway, immediately after this intersections definition you can use. That means A comma B will belong to each of these relations individually. And as individually all these relations are equivalents, what can you say? B comma A will be in this two. So in fact, B comma A belongs to R1 intersection R2. This leads you to conclude that R1 intersection R2 is symmetric. Yes, once you finish, inform me. Okay, Swan. Thank you. So now we are going for the last part, that is the transitivity. So for transitivity, we need three elements. We need three elements. For A, B, C belongs to A, or A, B, C belongs to A, we'll start with A comma B belongs to R1 intersection R2. B comma C belongs to R1 intersection R2. I should be concluding that A comma C belongs to R1 intersection R2. Very well, you can do it. From here, what I can write? AB belongs to R1 and AB belongs to R2. And BC belongs to R1 and BC belongs to R2. Very nice. Now you see, this is also in R1, this is also in R1. So you combine them first. AB belongs to R1, BC belongs to R1, and AB belongs to R1, BC belongs to R1, sorry, R2. Now, because both these relations are transitive as they are equivalents, I can directly write that A comma C belongs to R and A comma C belongs to, this is R1 and this is R2. You write the reason for this. So from here, what I can say, this belongs to the intersection. Therefore, R1 intersection R2 is transitive. Therefore, R1 intersection R2 is equivalence. That's a proof of this. That's a good proof, right? Yes. So we have done it. Now we'll go for the another part. Another part means second part. Second part is there that will go. Second part. Second part means we have to go for counter example. So we'll be taking counter examples to show that these are union may not be what uh, equivalence. So here let us consider one set first. 1 comma 2 comma 3 and two relations you consider R1. It should be reflexive, means 1 comma 1, 2 comma 2, 3 comma 3, all should be there. And then it must be transitive as well. So you consider this. So you will find the transitivity here. R2 you consider. Here we will not give the complete justification that R1 and R2 are equivalent. Just we'll write clearly R1 union, sorry, R1 comma, not union will not be equivalence. R1 and R2 are equivalence. You can justify by doing all the conditions. But here only we write the reason. This is not equivalence. Acha, why not equivalence? Because if you see, first before explanation, if you try to take the union of these two, all these elements will be together, right? So it will satisfy definitely reflexivity because 1, 1, 2, 2, 3, 3 all will be there. It will satisfy even symmetricity also. 1, 2 is there, 2, 1 also will find. 1, 3 is there, 3, 1 also will find. The only relation it will not satisfy is the transitive one. So that is our point where we will now write is not equivalence because R1 union R2 is not transitive as this is not transitive as you can see in the union both these elements will be there. So I want to pick one element from the first R1, that is it will be in union, this is in union, and one more element from the union. We have taken this. So if it will be transitive, I should be founding 2 comma 3 also. But this does not imply that 2 comma 3 is belonging to R1 union. So this is enough. This is enough. We have given you the counter example. This is enough. Yes. Okay. So now we'll go to the next board. Before I start function, some two important questions we'll discuss. I think question number it is 6. Give examples of a relation of the following type. Number 1, which is symmetric and transitive but not reflexive. So this kind of relation we can construct from our set. So I'll not ask you to do this. I'll do this. We'll consider the set as 1, 2, 3. And I'll consider one relation which should be symmetric, transitive, but not reflexive. Not reflexive meaning is that I should not get all the three ordered pairs. 1, 1, 2, 2. Remember it. And then I'll consider 1, 2 and 2, 1. That's all. Now you can see it is satisfying all the conditions except reflexivity. Why? Because 1, 1, 2, 2, 3, 3 is not there. But if you consider the symmetricity, it is here. As in when A, B is belonging to R, it should be giving you B, A belongs to R. It is true. As in when A, B, C belongs to R, A, C should be belonging to that set. Then it will give you transitivity. It is transitive, right? So this is a good example. Now one more question I can write from here, which is reflexive but not symmetric and transitive. This will be easier, of course, which is not symmetric and transitive, but it is reflexive, right? So what it will be? Let us take this set only 1, 2, 3 and R1. This time it should be reflexive, means all these elements should be there. And it is not symmetric. So you consider one such pair, right? And 2, 1 should not be there. It is not transitive as well, remember it. So if it is not transitive, I think if I close the bracket, that will be enough. No, that will not be enough. Sorry. If I close the bracket, one more ordered pair will be needed. One more ordered pair you write. Say 2, 3 you write. Because if it is not transitive, this should have given you 1, 3. That is not. So this is an example. You should write a justification. I haven't written. So with this, I'll finish with your relation part. Right? I'll go for now function. So before that, if you have any queries, you can clarify. Okay. So just today, I'll give the starting point of function. Okay? So that you can get a glimpse. Function is a very important part. It is a function. Function. After relation, we get function. Right? So function is one of the very, very important part, and this must be very, very clear. Right? So, what is a function? So first I'll write a definition. First I'll write a definition, then we'll tell you. With all these will be discussed with the help of figure so that it will not be messed up. But first you write the result. Let A and B be two non-empty sets. Non-empty sets. Then function is a rule. A function is a rule which associates associates every element of set A to a unique element of set B. Function is equal. I could have written the technical definition also. लेकिन technical definition जान के कोई ज्यादा फर्क नहीं पड़ेगा. It is better to understand the concept. That also I liked. Technical definition also I liked. This is what the understandable definition. So what does it mean actually? Okay. First we like, and we denote it. Denote it by how do we denote a function from A to B? This is the notation. This denote by this. F is a function from A to B. This is the notation. F is the rule that will tell you where there will be a condition afterwards. Once we take the example, then we will be getting. Now, if you ask me, suppose sir, you define it in symbolic way, so I can do it like this also. Let A and B be two non-empty sets. Then a rule F such that for x belongs to A, there exists a unique y in B such that f of x equal to y. So we can write it like this also. This can be also one of the definition. This can be also one of the definition. So actually, I would always ask you to go for this definition because this has simple wordings. Of today, I'll go off. Right. So I'll see you again on Saturday. Till then, do some problems related to this functions, what it is you see from 11 books.